All right, so this week we're a little bit late, but we're looking at zwasm. So the Z in zwasm stands for zig. This is yet another wasm runtime. We actually have I don't know 4 or 5 different runtimes available as packages on the repo here. Cut another one. This is coming in at a whopping 2 MB. Pretty slim. But it is also Zig, so not surprised. Why have like 6 or 10 hundredth WASM runtime? So I guess these guys are trying to cut the difference between like binary size, memory used, and also just performance. And so they kind of find a nice median. In this, you can kind of see how they compare to WASM time and WASM 3 by their own benchmarks. I say that they're, pretty spec compliant, and have support for Watt as well, which we're gonna probably look at. They have some great examples in here, whether it's C or Python or Watt or Zig, obviously. Hello in C, pretty straightforward. Uh, your Python, of course, whole bunch of Watt examples, and then some stuff in Zig as well. Uh, they do have some pretty decent documentation over here. One of the things that I clued in on is these different execution tiers. Basically deciding when to do one or the other. It's an interesting choice. I wonder if they'll keep that as this runtime matures. Uh, but yeah, let's go ahead and take a look. So we've got one example using our iBurg zwasm 130. And the config, all I'm doing is including this examples folder to make it easy, and then I'm passing in the argument of the wazi-hello.lot. And so you can kind of see it, runs it instantly, right? This is the actual Watt out that we have. Pretty basic. Now, here's the thing. You don't really write Watt files. You write it in the language that you want to write. So JavaScript, Python, Rust, Zig, whatever. Then it exports to this, and then you can load those up. So that's kind of how it's really meant to be ran. As I said, there's nothing special about this config. I'm just including the examples directory from the repo, which is all of this shit. So we got Fibonacci and so forth. We can, maybe show you that. I think I have it in my history here. So again, we're just loading up the package config. We're going to point it at the Fibonacci example. Then we're going to say invoke. So invoke is one argument that you can pass it, and so you can call the actual function rather than like the start function, like the main. And that way, I guess that's easier to test in some cases. And it also just kind of points at like the fact that this is a runtime, and so you can do a whole bunch of other stuff while we have this. While we're looking at the CLI help documents, you can kind of see a bunch of other stuff here too. So like right off the bat, we have some capabilities that we can kind of throw in. Sandbox, I haven't really looked at this thoroughly yet, but that's an interesting flag there. And then obviously our tracing is pretty essential for figuring out performance and things like that. But yeah, back to our Fibonacci. We can go ahead and run that and calculate fib of 10, which is 55 apparently. Is that? Yeah, that sounds about right. And then, obviously our package itself, zwasm, so it's pretty big, very basic. Very basic, yeah, so it's not even, it's statically linked, which is great. And then the actual binary size is 773. Wonder if it's not stripped, I wonder if we strip it, how low can it go? Yeah, so it dropped in size quite a bit, 7.3 to 1.3. Then our manifest is, pretty basic, nothing special. And yeah, we have literally nothing on the file system at all. But yeah, this is a quick and easy one. This just adds to the repertoire of our wasm runtimes that you can run as unikernel packages. So and now it's running as an Nanos unikernel. So we'll catch you next week, which is actually probably this coming Sunday. Because like I said, this one was a little late this week. All right, till next time.